Hello, everyone. Marcus back here with a Vaadin webinar. Really excited about this month's webinar. With me, I have my friend Petter Holmström from Vaadin, Principal Software Engineer, if I have it correctly.
Yes,
hello. Hello. You've been with the company for a good while, and if I don't recall entirely incorrectly, you were one of the first people who were involved in building a more or less official integration with Spring and Vaadin back in the day.
Yes, that's correct.
And you've, in your kind of work over these years, you've been involved with projects large and small, architecting and planning, and I guess the kind of top thing is learning a lot, because you're in a unique position where you see so many projects when you're working. So
oh yes, I've seen a bit of this and that during the years.
So I think that's a good starting point for just kind of learning a lot and kind of distilling down some ideas around what works, what doesn't work, and maybe gathering. It's hard always to say what's best practices, but you definitely know things that work better and things that work less well.
Yes, you learn from mistakes, both from your own and others, and it's of course it's usually nicer to learn from others' mistakes.
Exactly. All right, so during the presentation, I'm going to hand over to Petter real soon here, but as always, feel free to ask questions in the chat, whether you're on YouTube or Twitch or Facebook or wherever you're watching this, and we'll answer those questions towards the end of this. So I think that takes care of all the stuff we need to get through, and then I will hand over to you, Petter.
Thank you, Marcus. All right, so topic of today's webinar is going to be securing Spring Boot-based Vaadin apps. And well, it's a very large topic, and we could arrange like a series of webinars about this, so we have to narrow down the scope a little bit in some way. So we're going to look at a specific sample application that I built. It's a little bit more complex than your regular Hello World application, but it's still simple enough so that you can focus on the essentials, which are the security parts. And then we're going to take this application, and then we're going to look at some common threats and look at how those threats have been handled or mitigated inside this application. While doing this, we're also going to look at how the upcoming Vaadin 21 is going to make security much easier, especially when you're working with Spring Boot and Spring Security. And then we have some caveats to be aware of when we're securing Vaadin apps with Spring Security. And I'm not going to do any live coding today because there just isn't any time for that, but we're going to spend quite a lot of time looking at this existing sample application. The application is a simple mailing app. The concept is that users can send messages from one mailbox to another, and every mailbox is owned by a user, and then owners can grant other users read or write access to their mailboxes. And then we also had administrators that can create new mailboxes, and the sources are available on the GitHub. You can see this, the link here in the presentation. So go ahead and go there, have a look at the code. I can briefly show you the application as well. It looks like this. So I can log in, for instance, as a administration. And then we have different views. We've got messages here. This is an admin view where we can create new mailboxes. I can open, view, send messages and received messages. I can send messages from one user to another if I want to. And I can also manage access to another user. So for example, if I want to give Maxwell Smart read permission to my mailbox, I can do that. And now if I were to log in as Maxwell Smart, let's do that.
Can you zoom in a little bit on the app when you open it, just so?
Yes.
Perfect.
So now when I'm logged in as Maxwell Smart, I can see my own mailbox, but I can also see Bruce's mailbox. And as you can see, I can compose messages while I'm in the Max mailbox, but it's disabled while I'm in the Bruce mailbox. And that's essentially the sample application that we're gonna look at. So the UI is not much to look at. I haven't really focused too much on the UX. So we're probably gonna spend most of the time in the source code because that's where all the interesting parts are. So the threats, what are we gonna look at? I decided to start with the OWASP top 10 threats. And those are listed there on the left side screen. So we have injection, different types of injection attacks. We have broken authentication, sensitive data exposure, XML external entities, broken access control, security misconfigurations, cross-site scripting, insecure deserialization, components with known vulnerabilities, and insufficient logging and monitoring. Now, no Vaadin application is inherently immune to any of these threats. So whenever you build a new application, you need to be aware that these threats may or may not apply to your particular application. And that applies to this sample app as well. So not all of these threats are valid to this particular sample application. So I'm going to limit these presentations to those threats that are. And unfortunately, I have to leave out the logging and monitoring part as well, because that's we could spend an entire webinar talking about that. So what we're going to look at more concretely today is, first of all, how do we do authentication with OpenID Connect? What do we need to know about session management in a Vaadin app? How do we do OpenID Connect logout and backchannel logout? Then we're going to look at CSRF. We're going to look at XSS. We're going to look at how to prevent injection attacks, how to enable HTTPS in a Vaadin Spring Boot app. And then we're going to look at role-based authorization and what I've chosen to call user-based authorization within the application itself. And finally, we're going to look at some security context caveats in Vaadin apps. Before we begin with actually looking at the code, I just want to point out that we have this page, https vaadin.com/security. We'll publish all vulnerabilities found in Vaadin at this page. So you should monitor this list and update your software whenever needed. Registered users will also get email alerts whenever we publish a new security vulnerability report. Right. And then also in Vaadin 21, stuff that's coming and that we are going to look at in the IDE, helper classes that makes configuring Spring Security a lot more easier than it was in Vaadin 14, for instance. And also the new view-based access control annotations. So if you see something in the code that doesn't look familiar, it's because it's a Vaadin 21 feature. I'm going to try to point this out to you so that you're not confused if you're trying to do the same in Vaadin 14. Right, so let's start with the single sign-on authentication. If we look at this OWASP list of threats, what they list in this broken authentication part, it's a lot of things there that you have to think of. It's not just about asking for a username and a password and then trying to match them against a list that we probably with some kind of hashed password. There's more to this than that. We have to protect against different types of attacks, different kind of brute force attacks, dictionary attacks. We have to worry about password policies, two-factor authentication, reliable password reset mechanisms, and so on. And this is way too much to have to implement from scratch each and every time. So that's why I really recommend that you should go for an existing industrial strength tried and true identity management solution instead of trying to reinvent the wheel yourself. And also rely on standards such as OpenID Connect instead of inventing your own protocols. So that's exactly what we've done in this particular application, and we're using Keycloak and OpenID Connect. And if we start by looking at how I've set up Keycloak, this isn't a Keycloak webinar, so I'm not going to show you how you do it, but I have a separate client over here, the webinar sample app, and then I have the users over here that have different roles within this app. So for example, Bruce Almighty here, he's got the admin role and the user role, whereas if I go to John Smith over here and look at his roles, he's only got the user role. And then I'm getting those roles over into this sample application. And now let's have a look at how this is actually done. So setting up OpenID Connect used to be quite difficult in a Spring application, but nowadays it's surprisingly easy. So the first thing you have to do is to just configure some information about your OpenID Connect instance. So in this case, I'm declaring my custom Keycloak over OpenID Connect provider. I'm passing in the issuer URI. This is currently running on my own local machine. And this is actually the only URI that you need to specify, because Spring Security is able to look up all the other URIs from this one here. And then we also need a registration. So we need to provide the client ID and the client secret and the scopes that we're going to need when we are performing OpenID Connect authentication. And in this case, it's important to include this OpenID scope here, because without it, we're going to be performing an OpenAuth2 authentication instead, which is pretty similar, but it will result in a different authentication token class being used inside your application. And that will disable OpenID Connect logouts, which is something we're going to talk about in a minute. In this sample application, I actually have two registrations here. This is the registration that is used by users to authenticate. And this is a registration that I'm using for server-to-server communication, because I'm using the Keycloak REST API to look up users in the UI when I'm granting access to different users and so on. And then I need a different authentication token. So I need to have two separate registrations here. Right, so this is the property stuff. This is all pretty well documented in the Spring Security documentation as well. However, this is not enough. We also need to do a little bit of coding. If we look at the configuration, so that would be the security config. And this file used to be quite large in Vaadin applications, but now it's surprisingly small. And now I also added some additional stuff that you don't necessarily need in all your applications. So first of all, I want to point out that we're extending this new Vaadin 21 class, Vaadin Web Security Configurer Adapter. And this does a lot for us already. So it's setting up all this stuff that you had to do on your own in Vaadin 14, like how to handle CSRF, the request cache, setting up the new view access stuff, and so on and so forth. So this is something that you are now getting for free by the framework. So we're extending that one. And then we're going over to configure. Really important to remember to call super.configure, otherwise we'll lose all the goodies that Vaadin 21 is providing for us. And then what we need to do is just call HTTP OpenAuth2 login. So we're setting up OpenAuth2 login. And since we had the OpenID scope in our properties files, this is actually an OpenID login. We're registering our client registration repository. This is something that you don't always need to do, but in this case, we want to use it because we're also using OpenID client logout. And we're going to talk about that a bit later. Then we need to customize our user info endpoint so that we can get the authorities from OpenID Connect into Vaadin. And we're going to look at this as well in a moment. And finally, we set up a success handler, which is this Vaadin saved request aware authentication success handler. So this one is also provided by Vaadin 21. And essentially, it redirects you back into the view that you were trying to request when you were redirected to the login, but it's also Vaadin aware, so it takes care of certain things like, for example, the CSRF token and so on. So that's the login part. And the next thing is actually a little bit more interesting, at least in my opinion, because it's very easy to think that security, well, that's login. All right, so you managed to log into the application, you've authenticated the user, we're out of the woods. That's it. But it's a little bit more involved than that. If you look again at this OWASP list of threats, they also mention that it's equally important to be able to close your session. So you need to be able to log out. The session should expire automatically. If you haven't touched the application in some time, you need to change the session ID after a successful authentication to protect against session fixation attacks, and so on. But there's a little bit more to this than meets the eye, especially when you're working with a Vaadin app, and especially in this case, in this example app, because the session is actually 3 sessions. We've got an SSO session. In this case, it's in Keycloak. Then we have an HTTP session running inside the embedded Tomcat container that's inside of our Spring Boot app. And this is this one that contains the security context, which means that the HTTP session contains the credentials of the currently logged on user. And then inside the HTTP session, we have the Vaadin session. Now, if you log out, which sessions should you invalidate? And do all of these sessions expire at some point? And what happens then? So let's have a look. We only invalidate the Vaadin session. So this would be, you call Vaadin session.getCurrent. I think it's invalidate. And this is the one that I think is presented in the Vaadin documentations for how to log out. If you're using Spring Security and OpenID Connect authentication, this means that when you log out by just invalidating the Vaadin session, you just need to refresh your browser and you're back in. Because the HTTP session is still valid, it's still alive, it's still logged on. All you do is get a new Vaadin session and you can continue to access the application. So clearly, in this case, invalidating the Vaadin session is not enough to log out. All right, then we're gonna change the code a little bit. We will introduce a Vaadin session event listener that invalidates the HTTP session as well when the Vaadin session is invalidated. In this sample app, if you do this, and then you refresh your browser, you can again access the application because the SSO session is still valid. So you will get directly logged on again, even though you destroyed both the HTTP session and the Vaadin session. And then if we only destroy the SSO session, as long as the HTTP session and Vaadin session are still valid, you'll still be able to access the application. So we clearly need to think a little bit about which sessions do we want to destroy whenever we log out, and which sessions should expire and how fast or how slow and so on. Now, it's pretty clear that in this case, we want the HTTP session and the Vaadin session to follow the same patterns. So if the Vaadin session is invalidated, we want the HTTP session to be invalidated as well. The SSO session, well, it's a little bit more application specific. If we're using the identity provider for a single application, we probably want to log out from the SSO as well when we log out from the application. But if we have many different Vaadin applications and we want to use the same single sign-out or single sign-on session for all of them, then we probably want the SSO session to stay active, even though we will killing and closing these individual HTTP or Vaadin sessions. So the SSO logout and expiration, it depends on your use case. Speaking of expiration, here's another thing to be aware of. As you probably know, if you've been using Vaadin, it has these heartbeat signals that make sure that the server is still active and responds to the client. And these heartbeat signals are keeping the HTTP session alive. And as long as those heartbeat signals keep going, the session is alive, which means that in theory you can have like an application that's alive and well until you close the browser window. And that's normally not what you want. You want the application to automatically log out at a certain point. So that's why we have this Vaadin.close idle sessions property, which should also be familiar to all of you. So we set that to true. And that means that if the Vaadin session hasn't received any other traffic than the heartbeats for the session timeout, in this case, we're going to call it n minutes, then the Vaadin session will be expired. However, it's only the Vaadin session that's expired. So the HTTP session still is alive for another n minutes unless you have explicitly added this session listener that will kill the HTTP session. Which means that if you don't do anything except set this close idle sessions to true, and then you configure your timeout to be 30 minutes, it's actually going to be 60 minutes. This is also important to be aware of because like I said, as long as the HTTP session is active, you can still access the application. Right. Let's go back to the code again and have a look at this session stuff that I just talked about. Session fixation protection, so that is changing the session ID. That is happening automatically with this configuration, so I don't actually have to do anything about that. The session timeout I can configure over here in my properties file. So in this case, I have it set to 1 minute here, just so that I can try and test and demonstrate things. I've also changed the Vaadin heartbeat interval to 10 seconds. Normally, I think it's 5 minutes. And then I've also set this close idle sessions to true. And then over here, I have this Vaadin session configuration code that actually does two things. First, I have this session destroy event listener. So it's implemented by, actually, I'm implementing a session destroy listener interface. Then I'm implementing the Vaadin service init listener as well, and also the system messages provider. When the service is initialized, I am registering the session destroy listener, and I'm setting the custom system messages provider. And then when the session is destroyed, so we have to remember this is the Vaadin session, We also want to invalidate the underlying HTTP session, which leads to this somewhat funny code, getSession.getSession.invalidate. With this code in place, it means that whenever the Vaadin session is destroyed, we're also destroying our HTTP session, which is what you want in this case. Another thing that we're doing here is we need to decide what's going to happen when the session expires. And normally you would just get, I think you will get a pop-up message that says that the session has expired, and then when you click it, it will just reload the page. But in this case, we want to navigate away to some other URL. In this case, it's a static HTML page that just says that your session has expired. Click here to go back to the application. If you're okay with the default method, you don't need to do this customized system message thing. But I've found that in many cases, you want to change this to something else. So this is how you do it. And if you also want the SSO server to log out when your session has expired, you would have to change this to your logout URL. Which brings us to the next topic, which is OIDC logout. I'm going to take my little sip of water. Right. So when you're logging out from your application, you can choose to also log out from your OpenID Connect provider. So in this case, Keycloak. And you will do this through something that's called OpenID Connect Logout, which is part of the OpenID Connect standard. And essentially, it means that your application will redirect to the OpenID Connect server. So in this case, Keycloak, and then Keycloak will log out, and then it will redirect you back to your application. And this is all built into OpenID Connect. And Spring Security also has built-in support for this. And it's quite easy to set up. Again, we are here inside our security configuration class. We do this by registering a special logout success handler, which is this OpenID Connect client-initiated logout success handler. So this is a class that Spring Security provides for us out of the box. We need to create it. We need to specify the URL that you want to get redirected to after a successful logout. So in this case, it's a logged out, which will, in our example application, translate to a static logged out HTML, which says you have been logged out. And that's all you need to do in order to enable OpenID Connect Logout. Spring Security will take care of the rest. However, there's one more thing. If you want to log out from your Vaadin application, which is what we're doing in this, let me show you logout util here. This is what we're doing when we're logging out. So when I click a button, logout button, I'm calling the logout method, which will just change the location of the current page to the logout URL. This is how we've been doing it for as long as I can remember, also in the early Vaadin Spring days. However, with the default configuration, this won't work. And the reason for this is that if you have Spring Security CSRF protection enabled, which we have nowadays, except for internal Vaadin requests, the logout URL only responds to post requests. And not only that, it also requires that post request to have a CSRF token with it. And that CSRF token is the Spring Security CSRF token, which is not the same as the Vaadin CSRF token. So instead of trying to somehow work around this, the easiest way to fix it is just to change our logout URL so that we can respond to GET requests as well. And when you do this, we say that we will trigger the logout whenever we receive a GET method to the /logout URL. Then we can use this code that I just showed you that just essentially navigates away from the application into the logout URL. And then Spring Security will take care of the rest. So as you can see, in this case, we're letting Spring Security handle both the login and the logout for us. So we're essentially only using Vaadin inside an active session. And this is, in my opinion, a best practice that I've used in many production applications as well. Right, let's continue. I can see that I've been talking for half an hour already, so I have to speed things up. There's also something called a back channel logout. This is essentially single sign out. It means that whenever you log out from your OpenID Connect server, you will get logged out from all the applications as well. Sometimes this is what you want. Sometimes you really don't want this. I worked in some customer projects where there's even a government demand that in order to use like a government formal authentication service, you have to have either front channel or back channel logout support. This is also OpenID Connect standard stuff. I've chosen to cover back channel logouts here because that's what Keycloak supports. Essentially, it means that whenever you log out from Keycloak, you will receive a logout token that is sent over to a REST endpoint inside your application. Then you can verify that token, and then you need to invalidate the sessions that are associated with that particular token. This is not yet supported out of the box by Spring Security, but it is coming in a future version. I've shown how to do this in the source code. That's what we have, these session repository listeners, and so on. And but I think we won't have time to look at it in more detail right now because we have a lot more material to cover. But if you're interested in back channel logouts, check out the source code. I've tried to write comments with the relevant at the relevant classes so that you can understand what's going on. And if there's something unclear, you can just file an issue, for instance, in the GitHub repository, and I'll improve the documentation until it's clear what's going on. Right, let's move on. CSRF, we have already covered this a little bit, but to summarize, Vaadin has built-in CSRF protection, and Spring Security also has built-in CSRF protection, and these are not compatible. And previously in the Vaadin 14 days, the way you fixed this was that you disabled Spring Security CSRF protection completely, and then you just relied on Vaadin CSRF protection. In Vaadin 21, we can actually use both. So this base class that I just showed you, it will disable Spring Security CSRF for the Vaadin requests while keeping it enabled for all other requests. So for example, if you're ending up implementing a form login with Spring Security, you can use CSRF for that part. And then when you get over into the Vaadin application, Spring Security CSRF will step back and Vaadin CSRF will step in. Then moving on again, XSS. So Vaadin has built-in support against XSS attacks as well. You can find information about this if you go into the Vaadin documentation, this topic about security over here. This is a recommended reading for everybody who is implementing secure Vaadin applications. And it's also covering quite a lot of the stuff that I'm talking about today. For example, this CSRF, here's a little bit more information about what's happening under the hood. Here's the information about cross-site scripting, and we have some other vulnerabilities listed here as well. So this is, in addition to looking at the OWASP 10 list, this is also a good reading. Moving on, XSS in Vaadin, we're using browser APIs that normally render all the contents as text. So even though you have tags inside, for example, a label or inside a text field, it will be rendered as text on the browser side. It's not treated as HTML. But we also have support for rendering HTML when explicitly ordered to do so by the developer, for example, using this HTML object. Or we can also execute arbitrary JavaScripts, both on the client side, and also we can initialize them from the server side as well. And in these cases, you need to be extra careful as a developer. So you need to know when you're entering into dangerous territories. So whenever you are generating something that will actually be interpreted as HTML or JavaScript on the browser side. But the default in Vaadin is to render content as text. And this brings us into injection attacks, because XSS and injection attacks, they are kind of the same way of attacking. Typically in a Vaadin application, you have to deal with two types of injection attacks. So we got SQL injection and we got JavaScript injection. And SQL injection, this shouldn't be like new to anyone who has been working for some time with web-based database applications. You don't append query arguments directly to a query string. Instead, you use these query parameters. For instance, if we look at this code here, let's look at some repository code. I don't think I have a string example here. Well, actually, I do. So here we have a query, find mailboxes. So if I were to just build this query by concatenating strings, so where m.owner equals, and then I put a quote, and then I add principal.getName, then if the principal name happened to include a JPQL code, I'm just being subjected to a injection attack. However, in this case, I'm using these placeholders, so principal and permissions, and then I'm filling in the parameters as query parameters, and then I'm letting, in this case, Hibernate deal with escaping and sanitizing this input in such a way that I can't perform a SQL or JPQL injection attack. So this is a best practice that you should apply whenever you create a query. And then if we look at how to protect against HTML and JavaScript attacks, this example application, it's using the rich text editor to edit and write messages, and then it's sending showing them as HTML. So if we look at this message view, Vaadin view, this is where it shows the actual message body. This one is coming from the database, which means that it's untrusted. And here we're using the HTML object, which means that whatever we put inside here will actually be rendered as HTML. So in this case, I'm using the OWASP HTML sanitizer to sanitize the message. There are other tools as well. I think JSoup is one, and there are probably all kinds of ready-made utilities that can sanitize a string to make sure that it doesn't contain anything that shouldn't be there. So for example, in this case, I've configured this sanitizer to support formatting. So that's like bold, italics, then it supports blocks. I can use CSS styles, and I can also use links. But all the other stuff is sanitized away. And this is something that you should be doing in your applications as well. So whenever you know that you're gonna have to show something that will be rendered as HTML, you need to run it through some kind of a sanitizer, unless you're absolutely sure that it's completely safe and completely trusted. And like I said, just because it's been stored in the database, it doesn't mean that it's trusted, because databases can be tampered with, or there might have been a problem with the validation when the data was inserted into the database, or it might have been imported from some external database, or something like that. So always be extra paranoid when dealing with HTML and also JavaScript. JavaScript I don't have an example of in this sample app, so I'm not going to cover it, but it's mentioned on the Vaadin documentation page. Right, moving on. HTTPS. This used to be difficult, something that you wouldn't do until the very end. Nowadays, it's really easy to do, so you should try to do it as soon as possible so that you don't forget about it. In a Spring Boot application, it's a matter of generating a certificate inside a Java key store. I'm not going to show you how to do that because the web is full of examples how to do it. And then we go back to the application properties file, and then it's these 4 lines that you need. So we need the key alias of the certificate, the location of the key store, the password of the key store. And then when I call this enabled equals true, it means that the only way to access this application is through HTTPS. So if I try to access this port with HTTP, the browser will complain that no can do. And that's it. So that's how you enable HTTPS. If you're using self-signed certificates, you're probably going to have to deal with some trust store issues. For instance, in Chrome, the first time you try to access a page with a self-signed certificate, it won't allow you to proceed. So you have to enter "this is unsafe" on the keyboard. And once that is done, it will let you through, and then you can do whatever you want. And also, in the sample application, when I implemented the back-channel logout, I also had to configure Keycloak to ignore certificate validation issues, because it wouldn't recognize my self-signed certificate when it was sending over the logout token. So these are just issues that you have to deal with. And of course, when you go into production, you should use a real certificate, not a self-signed one. Right, moving on to authorization then. So I already mentioned in the beginning when we looked at the OpenID Connect that we need to get the roles from OpenID Connect into Spring Security so that we can actually use them in our code. And this isn't something that happens by default. By default, you will just get a role user, and then you will get roles for all the scopes. And then you will get one special OpenID Connect authority, which will contain everything. And it's that authority that we're interested in. So in order to get those authorities out from the token, we have to do a little bit of coding. Let me see if I can find the correct. So first thing, we go to the configuration class, and here we have the user authorities mapper. So this is part of the Spring Security API. And then we need to implement our own granted authorities mapper. And this one I have implemented over here, because it depends on how your OpenID Connect provider has been set up. So for example, in this case, I can get the roles that I had defined in Keycloak. So we had user and we had admin. And those are included in the ID token that I'm receiving from the OpenID Connect. And depending on how you configured it, they are behind a specific JSON path. So in this case, it's resource access, and then below that, there's the client ID, and then below that, there is a roles, and that one contains an array of the role names. So this is essentially just that. I'm getting this open auth2 user authority that's been provided to me by Spring Security. I'm going through the attributes in that one to find the roles that I'm interested in. And this, like I said, depends on how your OpenID Connect provider has been set up. And then I'm just converting those roles into simple granted authorities and returning them over here. And what does this mean? Well, it means that once I've done this, I can start to secure my services, for example, like this. So here is the mailbox user role. Here is the mailbox admin role. And by using the secured annotation on my backend services, I can secure them. So this is a method that's service that's only available to users, whereas this is one that's only available to administrators. But that was on the backend side, and now we want to handle access in the front end side, so the UI as well. So that would be Vaadin 21 in our case, and now we have some new fresh support for granting access to different roles on a view specific basis. So this is also all covered in the documentation, but you can find some examples. So whenever we have role security allowed, Spring will deny access to all views by default. So if you forget an annotation, you will not be able to access your application at all. And this role-based security for Spring apps is automatically enabled whenever you use this Vaadin Web Security Configurer adapter. You can use it outside of Spring Security as well, but that's out the scope of this webinar. So, for example, in this case, the compose message view is available to users, whereas the mailbox admin view is only available for admins. And this is all you need to do. Spring and Vaadin will take care of the rest. So if you don't have the correct roles, if you're in development mode, you will get an error when you try to access a protected view. And if you're in production mode, it will just act as if the view doesn't exist. So this is a lot easier than the old times when you had to manually take care of this with all kinds of access control features and then or navigation listeners or something like that. I don't even remember how to do it anymore because this new way is so much better. And if you want to find out more about that, then you should go here and look at this view. It's over here, view-based access control in the Vaadin documentation. It explains everything, how to set it up. This is how to set it up without Spring. And you can also find information about how it works with Spring. So this is something that's going to make at least my life a lot easier in the future once Vaadin 21 is released. Right. We are going to go slightly over time today, but since we don't have any other programs waiting for us, I'm just going to go on. And if you have to leave, then go ahead and leave, and you can watch the end at the ending in the recording afterwards. So far, we've been only talking about security features that come out of the box. They are provided either by Spring Security or by Vaadin. And in simple applications, that's probably good enough, but in many cases, it's not. For example, this sample application, we want to be able to grant specific permissions on specific mailboxes to specific users. And this isn't something that you can just rely on a framework for. And you actually have to build this into the domain model of your application. And I'm not going to show you here now exactly how this is done, because it's different from application to application. The point I'm trying to make here is that security isn't something that you just can slap on top of your application once it's done. I mean, we've seen what happens when you do that. All our internet protocols were designed in this way. We assumed that all the users would be reliable and have well intentions, and then later realized that, oh, we actually need to add security, and that's when we started adding HTTPS and all things on top of all these clear text protocols. So don't make that mistake. Instead, take the security into consideration from day one and build it into your application where needed. And if you want to know how it's actually handled in this case, just go to the source code and have a look. For example, the message read service here, we're checking when we are querying for mailboxes whether the current user has access to it, and if not, we're just removing it. There. Moving on. This is an issue that you often run into when you first try to use Spring Security and Vaadin together. And it's actually there are two issues, and they are related, but they will lead to different things. And this is leaking the security context. Now, if you don't know what the security context is, a really quick refresher. So in Spring Security, if you're using a servlet environment, there is always a security context that is bound to the current thread. And this security context can contain an authentication token, which is used to authenticate the current user. And you can accidentally end up leaking this security context from one session to another. I've tried to illustrate it on this blue image at the right-hand side of the screen. And this typically happens when you're dealing with events. So you do something in one UI session which triggers an event which should lead to all the other UIs refreshing themselves, for example. And if you implement this in the wrong way, so that you have like a synchronous event bus, for instance, so that your event bus is just a list of listeners, and whenever the event is fired, you will just loop through all those listeners and call them immediately, and each listener will then refresh their own data. You're actually doing this inside the same thread using the security context of the user that originally fired this event. So in the worst case scenario, this means that if Alice is firing an event from her browser, and Bob receives the event, and then the Bob session will refresh itself, and it will end up showing Alice's data in Bob's screen. So that's really not what you want. And I can show you how to deal with this. I've addressed this problem in the code. There is no like a one-size-fits-all solution to this problem. But you need to be aware of it so that you can treat it correctly from time to time. In this particular case, we only have one event that is sent. And that's this message sent event. And we're using that so that our message list views can update themselves whenever a message is received. And to do this, I've implemented this really simple message sent topic class, which is an application listener. So it's receiving a message sent events from the Spring event bus. And then I have a list of subscribers here. And the first thing I'm doing is that I'm invoking the subscribers in a separate thread so that I'm not at least leaking the security context from the calling thread into the others. And then I'm also clearing the security context between each subscriber invocation so that if something were to happen to the security context inside this method, then it won't leak into the next one. You could also deal with this by, for example, invoking each subscriber in its own thread. But if you're using a thread pool, which you should, then you need to make sure that you still clear the security context afterwards so that you don't end up leaking some old security context somewhere. So whenever you're dealing with events or messages that are going across session boundaries, you need to be aware of the fact that you don't want the security context to go with this event, except maybe in some special cases. The next issue that you can run into, which is probably more common because this one, before I go on, this one is difficult to detect when you are testing things on your local machine because you typically only have a single session. So you may not actually realize that this is a problem. Or if you have two sessions, but they are logged on as the same user, you have some test user, then you also won't detect this problem. Whereas this one will clearly show you when it happens. And that's that you don't have a security context at all. This typically happens when you're inside UI access. So you're doing a server push from Vaadin UI. We have to understand that in a servlet-based Spring security application, this security context is automatically populated while an HTTP request is in progress. So there's this filter chain that whenever a request comes in, an HTTP request comes into your application, it goes through the Spring security chain, which does a lot of it. And one of the things that this chain does is to fetch the current authentication token from the session, store it in this security context so that it's available when the request actually reaches Vaadin, and then it does its work, and then it goes back through the chain, and then the security context is cleared. Problem is that you can call a UI.access from any thread you like. You can call it from a background thread, or even if you're calling it from an HTTP request thread, it may actually end up being executed by some other thread, depending on different circumstances that I'm not going to go into here. But anyway, if you end up in a situation where you call UI.access and there isn't any active HTTP request, then there won't be any security context either. And if you try to invoke a protected backend service, then you will just get an access denied message. This is a problem that we've seen from time to time in our forums and on Slack Overflow. And you can solve it in two ways. I'm going to show you one of them. It's over here. Again, a little bit about how Spring Security actually handles the security context. So you access the security context from something called a security context holder. And that holder uses the strategy pattern so that you can decide how to actually store and retrieve this context. By default, it's using a thread local, but there are other alternatives as well. In this case, we want to extend this thread local security context holder strategy so that if there isn't any security context in the current thread local, we want to try to fetch it from the Vaadin session instead. And this is what we're doing here. So This behaves exactly the same as the thread local security context holder strategy, except if there is no context in the thread local, then we will see if there is any Vaadin session. If there isn't one, we will just act as if there is no security context. But if there is one, we will try to get the security context from the HTTP session and then return it. And in order for the Spring Security holder to be able to access this and use this, we also have to set up the security context holder, set strategy name, and then we're passing in the name of this holder strategy. For some reason, you can't pass in the class directly. And also, the reason why we're implementing this from scratch is that this thread local security context holder is final and package protected. But as you can see, it's the same implementation. So by doing this, you can avoid these strange access denied errors inside UI.access calls. And that's actually all that I was going to cover today. It's been quite a lot of information. I've tried to compact it as much as possible. If you feel a bit confused right now, it's perfectly fine. The solution to this is to wait for the recording, and then you will watch the recording again, and then you will place the pause button and go to GitHub and look at the code, try to figure it out your own. Then you will continue watching the webinar, go back to the code. And if you're still confused, you file a issue in the GitHub or otherwise ask a question in the channels that we have, and then we'll sort it out.
Well, thank you, Petta. That was a very refreshing drink from a hot fire hose.
Oh, yes.
So I know we're at 1 hour now, which is how long we initially intended this to be. But if anyone wants to stick around for questions and answers, if you have a few minutes extra time, Petta, I think we could still go through a few questions.
Yes, I haven't had time to look at the questions myself, but if you have any questions that you'd like to highlight, yes.
Yeah. Let's see here. Start from the beginning, so we'll go through here. All right, so we have first question here from Alexander is, should you use microservice architectures if you're using Keycloak with Spring on the back end and Vaadin as the front end, or can you use a monolithic architecture if the app is smaller?
Yes. You can definitely use a monolithic architecture if the app is smaller. That's perfectly fine. Microservice architecture is definitely not a requirement. It depends on your use case. If you have like a set of multiple applications that all should use the same Keycloak, then it's better to go for microservice architecture. But if we're talking about a single application, there's no point in going microservices for it. Just set up your monolithic app, set up your Keycloak, and let them communicate with each other, and that's it.
All right. Another one from Felix here. From the property file, I guess you're not using the Keycloak Spring Boot adapter. Why not?
That's a good question. I was thinking it would show up. The reason is that if you're using the Keycloak Spring Boot adapter, you don't have to, but the recommended way is to extend their own base class when you're setting up the security, because then it will configure everything for you. In this case, Vaadin has its own base class to extend. And since we can't extend multiple classes in Java, I just had to pick which one I wanted to use. And well, since we're Vaadin and it's a Vaadin app and we want to showcase the new security features, I ended up extending the Vaadin base class and then configuring Keycloak as just a standard OpenID Connect solution. So there actually isn't any Keycloak adapter at all in this, and works pretty well, even though I had to do a little bit of coding myself. But then again, the idea wasn't to showcase Keycloak, it was to showcase OpenID Connect.
Good. Well, speaking of connection adapters, there was a question here about version numbers. You've been talking about Vaadin 21. There was a question from Manfred here. If there are any chances this new Vaadin web security adapter configurer factory, whatever its
actually,
full name is, will be available in 14 at some point.
I can't answer that question because I don't know. We'll have to check the Vaadin 14 team. But it would be a valuable addition to Vaadin 14, and I don't think it would be too difficult to implement, but I can't make any promises.
Okay. All right. Let's see here. Let's see, we have, I think, 2 questions more. So is there best practice to figure out who's the authenticated user in another UI or session when accessing the UI?
So let's see here. The currently authenticated user of another UI. So in this case, I assume that you're not meaning the user that's currently accessing the browser, but it's the user of some other session that you're accessing. And well, the easiest way to get a hold of this is by accessing this other user's session. If I switch over to the code here. Here, for instance, if you have an access to the Vaadin session object of this other user, then you can also get access to the HTTP session of this other user. And if you have access to the HTTP session, you can get the security context of that other session. And then you should be able to access the authentication object from within this security context, and that would then be the authentication of object of this other user. You can also, of course, do this in a more custom way, so somehow storing the user ID directly in the Vaadin session, in which case you can get it directly from here. You won't have to go through the HTTP session and Spring's security context repository and so on. But that's the way I would do it. Of course, you should ask yourself the question: do you actually need to access the credentials of another user? Yeah. I guess there are probably valid use cases for when you want to do that, but normally you don't want to.
Yeah. Good. All right. I think that was kind of the bulk of the questions that were kind of related to Spring and Spring Security in any way. There were a couple of other questions that maybe we can answer in the chat that were more generic Vaadin questions. I want to really thank you, Petter, for joining us. There's a lot of super valuable information, and I think your suggestion of kind of watching this again on a slow speed and pausing whenever needed to go and check out the GitHub is a very good suggestion. I want to also remind people of our Discord chat. So it's on discord.gg/Vaadin if you want to come and discuss with us. I know Petter has been there on occasion as well, but there are definitely a lot of Vaadiners there that can help answer questions that you might have. And lastly, I'll just share the link to your GitHub once more here at the end of the stream, and I'll add that to the show notes below. All right, so thanks everyone for joining our webinar this month, and thanks again, Petter, for joining and sharing your wisdom with us. And
very welcome.
We might take you up on the suggestion of doing a series of webinars on other topics. There seem to be a lot to explore here.
Let's do that.
All right, so thanks everyone, and be sure to tune in next time. Bye.
Bye-bye.